You're clicking this glowing interface button over and over. Sparks fly, but nothing actually happens. The page is completely frozen. JavaScript is the engine that drives this kind of web interactivity. When it breaks, your site grinds to a halt. Knowing how to trace and fix these errors is a mandatory skill for any web developer. Today, we are going to track down and fix a broken piece of code using your browser's built-in developer tools, brought to you by Royal Research. You don't need to download any specialized software or third-party applications to follow along. Everything we need is already packed directly inside a standard modern web browser. By mastering these built-in diagnostic tools, you shift the debugging process from anxious guesswork into a predictable, step-by-step workflow. Step 1 is setting up our workspace. To find out why our button is failing, we need to look under the hood of the browser while the broken web page is still running. This split screen shows exactly how to get there. Just right-click the page and select Inspect, or use these keyboard shortcuts, Control plus Shift plus I on Windows, or Command plus Option plus I on a Mac to open the Developer Tools panel. Modern browsers pack a lot into this panel, but don't get distracted by the Elements or Network tabs just yet. We need to navigate directly to the Console tab. Look at this readout. The browser highlights exactly what crashed. We can see a reference error indicating a missing variable, and right next to it the number 24, telling us this crash happened exactly on line 24 of our script. This readout is highly specific, but it is only a diagnostic tool. The console tells us what broke and exactly where to look, but it cannot fix the code for us. Now that we have our target, Royal Research recommends viewing the actual architecture of the application. Move over to the Sources tab. On the left of this panel, you'll see a file tree. Use it to navigate through your project folders and select the specific JavaScript file the console just pointed us to. This diagram illustrates our next tool, a breakpoint. A breakpoint deliberately halts the continuous execution of your code at a specific intercept node. To place one, scroll down to line 24 and click the line number. A marker will appear, locking in your intercept point. Here is where beginners get stuck. The code won't pause on its own. We have to force the script to run and hit our marker. Return to the web page and click that broken button again. This sends a new data packet straight into our breakpoint. You'll know it worked when the entire web page dims and a banner reading "Paused in Debugger" appears across the top of your screen. By freezing time, you can now inspect the exact state of your application, looking at all your data right before the crash occurs. Sometimes stopping the code every single time a line runs is too slow, especially if you're diagnosing complex loops or repetitive data fetches. Instead, we can use a conditional breakpoint. This allows us to tell the browser to pause execution only when a very specific error state occurs. Right-click your existing marker and select Edit Breakpoint. In the text field that appears, type your logical condition, like checking if variable x is strictly equal to undefined. Once paused, you'll want to inspect your data. Rather than cluttering your script with dozens of static console log statements, use the Watch Expressions panel. Click the plus icon in the Watch panel on the right side of your screen. Type the exact name of the variable you want to track and hit Enter. Unlike static console logs that just print a single moment in time, Watch Expressions update live as you step through the code line by line. Combining conditional pauses with live variable tracking isolates the root cause with precision. You eliminate manual hunting and observe exactly what the data is doing. The Watch panel shows that a critical variable is returning an undefined state because of a syntax typo in its name. Now we know the exact problem. Switch back to your primary code editor, locate the typo on line 24, and correct the spelling to fix the logic flaw. Before you test, make sure to save the JavaScript file and fully refresh your browser to load the corrected codebase. By isolating and correcting the underlying logic flaw at its source, you ensure the core bug is permanently eliminated rather than just temporarily patched. The final step is validating our work. Go ahead and interact with that newly fixed UI button. The expected action fires and our success message slides smoothly onto the screen. Look at the Console tab next to our success notification. The panel is completely empty, confirming that the code is now executing without any errors. We followed a strict 4-step methodology. Check the console for location, open the sources for viewing, drop breakpoints to freeze time, and watch expressions to isolate data. Royal Research empowers developers to use these specific techniques to tackle complex issues. By applying them, you turn frustrating software bugs into manageable, step-by-step victories. Happy debugging!